Okay. So the one of the tips that I gave you last time was you look at the left-hand side and right-hand side, and you first have to look at the ones that occur only once in each side. Okay, so have a look. If you look at the oxygen, it occurs in too many different places, right? It occurs twice here on the left-hand side and 3 times on the right-hand side. So it's really not really easy to balance the oxygen at the moment. Well, you can see that sodium is Na here. It only occurs here once. It occurs here once as well, but uh, it occurs, there are 2 Na here because of this 2 here. You can see that, right? So obviously, what we can do is we can place 2 right here and 1 right here. That means sodium and the sodium here are balanced, isn't it? And if you can, so this may not work though, okay? So we're doing this by trial and error. So basically, if I let that equal to 1, then this has to equal to 2. Or if this is 2, then this must be 4, right? So just have to bear that in mind. Now, next thing we can do is, all right, so there is a hydrogen there occurring only once here, and hydrogen here occurring only once here. And as soon as I put 1 and 2 here, I've got 2 hydrogen, and I've got already 2 hydrogen. Oh, there's also a hydrogen here, right? So that's difficult. What about carbon? Carbon is C there, no C here, C there, nowhere else is C. So what you can do is, because I have 2C, maybe I should have 2C as well. Now, what else do we have to do? Okay, so let's have a look at sulfur as well. The sulfur only occurring once here and once here, right? So that means because this is 1, because I chose this to be 1, I think this has to be 1 as well. All right. Now, the only thing that I have to check is now this one here, right? So I already chose all these numbers. So I only have to choose this number right here. So I've got 2 hydrogen here and 1 of 2 hydrogen there. So there are total 4 hydrogen here. So 2 hydrogen and 2 hydrogen. So 4 hydrogen. And I've got 2 hydrogen here. So in order to get 4 hydrogen, I just have to put 2 there. But so let's check each of this. So we did this by trial and error. So we have to check all these numbers and see if they all work. The only thing that we didn't check is oxygen, really. So sodium here, so 2 sodium. So these are the ones that only occur once each side. So that's 2 sodium here, 2 sodium here, that's fine. Carbon, 2 carbon there, so 2 carbon there. So that's check. Sulfur, that's 1 sulfur there, 1 sulfur there, that's check. And hydrogen, that's 2 hydrogen, 2 hydrogen, so 4 hydrogen on the left-hand side and 4 hydrogen on the right-hand side. So that's check as well. So we did this based on these, but not based on oxygen. So let's see if oxygen works. If that doesn't work, that means what we did here is wrong. And what you have to do in that case is use a simultaneous equation, and that's a bit complicated. So let's have a look. So how many oxygens are here on the left-hand side, and how many oxygens are here on the right-hand side? I want you guys to work that out yourself. So here, my trial answer is 2, 1, 1, 2, 2. And based on these numbers, all these are balanced, except maybe oxygen, I don't know. So I want you to type your answer. I'll just unmute everyone. You can tell me with your voice what's the number of the oxygen on the left-hand side. So Chris, you're saying 10 on the left-hand side. Is it 10 on the right-hand side as well? Okay, so that means it's working. So sometimes it doesn't work, all right? Yeah. So the reason why you have 10 here is because you got O3, so 3 oxygen there, but you have to times that by 2. So you got 6 oxygen here. There are 1 of O4, so that's 4 oxygen there. Here you have 4 oxygen. 1 oxygen times by 2, so that's 2 oxygen. Here, O2 times by 2, so that's 4 oxygen. So that's 10 oxygen as well. So oxygen is also balanced. Okay. Now, I'll just mute everyone because it's a bit noisy. Now, question E. Let's try that. I think E looks pretty simple. So C4H10, O2, CO2, H2O. So as you can see, carbon occurs once on each side. Oxygen occurs once here, twice here. Hydrogen occurs in just one place. So I think if it's a C4, I'm just going to assume that this is 1. So 4, I'm going to assume that there are 4 carbons. Then I just have to write 4 here, right? Okay, 4 here. Then you end up with, so carbon is balanced, right? So carbon, give it a tick. Now for hydrogen, so hydrogen occurs here and here once. So there are currently 10 hydrogen here. So what should we put over here? You can type your answer. So what do we have to put here in order to balance them? So the answer is 5. Very good. So 5 times by H2, there are 10 hydrogen there, 10 hydrogen there. So hydrogen is now also balanced. Hydrogen is also balanced. So with 1, 4, 5 there, all of them are balanced. I mean, these two are balanced, but let's now look at oxygen. I still have to choose this number here, right? So at the moment, because I already chose these numbers, the number of oxygen here is fixed. Okay. So how many oxygens are here on the right-hand side? 13. That's right. So that's 2 times by 4. Yeah. So you have 4 carbon, but 8 oxygen. The reason is you have, this is CO2. That's a carbon dioxide. It looks like that with 2 bonds, 2 bonds. I'm going to talk about the bonds later. So you've got 4 of these. Remember last time when I said when you have a subscript, these things here, this indicates bonds, right? So for every carbon, there are 2 oxygens attached to it. So the subscript over here indicates bonds, all right? When you have coefficient, which is this one here, number at the front is coefficient. That indicates the amount of separate. Like this is separate from this one, isn't it? So these are 4 separate individual carbon dioxide. As you can see, there are 4 carbons and there are 8 oxygen, right? So that's what this one is. So you have 13. So there's 8 oxygen here and there's 5 oxygen there. So it's total 13. But what do we have to do here? So if I put 7 here, I get 14. If I put 6 here, then I get 12. So did I balance it correctly or wrong? So Chris is saying we put 6.5 there. Now Michelle or Philip, is that right? Can we put 6.5? Yes or no? What do you guys think? Can you put 6.5? Maybe. What about you, Philip? What's your opinion? I want to hear from you as well. Philip, you there? Don't know? Okay, so are we only allowed to put integer there? Like this is an integer, this is not an integer, right? So this is a half integer. Well, the answer is 6.5 is possible, but we usually put 13 on 2. This 13 on 2 is 6.5, isn't it? Yep, 13 on 2 is 6.5. And that's all right. This is so when you do 13 on 2 times by 2, you get 13, right? So that's fine. So maybe the reason why a lot of people find this difficult is because they think that 6.5 is not allowed, but it's fine. You can alternatively write the equation like this. So once you get this, oxygen number is balanced, carbon, hydrogen, they're all balanced, aren't they? But once you have half integer, sometimes some people don't really like to have half integer, but still with 13 on 2 there, it is balanced. That's important. Okay, that's all that is. That's all that really matters, that it is balanced. If you don't like the half integer, you can simply take this whole thing and times this by 2. So double everything. So this is a 2C4H10 with 13 oxygen there, and then 8 carbon dioxide and 10 H2O. Okay, so that's very that's all balanced. Okay, so either this one is fine or this one is fine. All right. So you balance this first and then times by 2. So that's the technique that I would recommend you guys to do. Now let's try I. I'll leave this one to you. You guys can maybe try. I'll give you a few minutes. C9 H10 O plus O2 CO2 with water. I think this one's pretty quite all right, I think. Yep, give it a go. I'll give you a few minutes. I'll be right back. All right, Chris has got something. So you got 1 here, 23 on 2 here, 9 and 5. Okay, so I'm going to double check. 9 carbon, 10, 10. So that's 5, 18 there, 18, 23. So 20, yeah, that's perfect. So probably you did this one first. You put 1 here, so you get 9 carbon. Balance the carbon first. And then you have 10 hydrogen. So put 5 here, right? Then you get, you got 10 hydrogen there. So in this case, if you choose 9 and 5 here, that means you end up with 23 oxygen. Oh, hold on, however. You got 23 oxygen. But the thing is that here, you have already 1 oxygen here, right? So it must be, yeah, 22. So it must be something like this. You put 11 there, then you end up with 23 oxygen here. Is that right? Yeah. Guys, just wondering, do you guys all see this white marker, my pen? You guys notice that, right? So when I'm not writing, when I just move around like this, can you guys see this thing moving? You guys do? So it's not, so it's exactly like a cursor, is it? Like a mouse. So you guys see this rotating, right? Okay, that's very good. Yeah. So yeah, you didn't have to put any fraction here. So if this one was like, if this didn't exist and all you had was 23 oxygen here, then you should have put 23 on 2, which is actually equal to 11.5, is it? Yeah, you should have put 11.5. Sorry, what'd you say? In front of H2O, I thought there was 4. I think it should be 5 because, yeah, this is 5 here. Because you have, as soon as you put 9 here to match the 1 and 9, then you end up with 10 hydrogen here, right? 10 hydrogen there. So in order to match 10 hydrogen here with this one, you need to put 5 there. Do you understand? So when you put 5 hydrogen there, 5 water there, that means you have 10 hydrogen. So 10 hydrogen there, so they're matched. Now if you count the oxygen number, that's 23, isn't it? Because 9 times by 2 is 18, plus 5 oxygen, so you get 23. So you got 23. So, and you already have 1, so that means there must be 22 oxygen here. And how do you have 22 oxygen? You have to put 11 there. And that's it, really. So that's the balancing of. So you can try all of this yourself. All the answers are found at the back of this workbook. This one here. So you guys all have this, right? So that's all found in the Facebook Messenger. Now we are going to move on to a different topic. So this is called limiting reactants. Limiting reactants. So as you can see, when you look at question 17, these are all something called reactions, aren't they? So they're all called reactions. So what do you think is a reaction, guys? Can you guys type reaction in your own words? Can you try that, maybe on the chat room? So you can start your sentence by maybe saying reaction is when blah, 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 blah. Okay. I'm going to bring the chat room over here. If you don't, maybe I'll not, yeah. You guys can just share the information to me personally if you don't want others to see. Just try. I'll give you like 30 seconds. So when you do science, and probably you saw some reactions before, what is a chemical reaction? I'll just wait for your responses. All right. I got one response. All right, Chris has shared to everyone. So reaction is a chemical response when two substances react with each other. That's pretty good. Okay, but does it have to be two substances though? Can it be three substances? Yeah, it could be multiple, right? Yeah. It doesn't always have to be two substances. Can you guys actually see these when you look at question 17, do you guys see they are all reaction by two substances, right? So the thing is that it can be three substances. Okay. Well, let me ask you this. Can it be one substance as well? Can one substance react by itself? Okay. What do you think, Michelle? Chris is saying no. And Philip, what do you think? Do you think reaction can happen with just one substance? Okay. Philip saying no as well. Michelle, do you think Michelle is saying reaction can happen by one substance? The answer is yes, it can happen with just one substance. So I'll show you an example. You can have something like water, so very common substance, right? This is called decomposition reaction. Decomposition reaction. Decomposition reaction is when a substance is broken into smaller things, and water can be broken down into H2 gas and O2 gas, oxygen gas, which we breathe, and hydrogen gas. Can you guys try to balance this one? So obviously this one is also a reaction, okay? So try to balance this one now. And I'll read Michelle's answer. Yeah, Michelle's answer is pretty similar to Chris's answer, but it's got a little bit more details, I think. Okay. So we've got the O2 there. There's one O there. So we can put 2 there. So then you get 4 hydrogen. So just have to put 2 there and 1 there. Okay. So 1 O2, that means 2 oxygen. Put 2 there as a response. So you do this one first, and then you do this one, and then you do this one. Alternatively, have a look at this. You can also have, so H2O decomposing into H2, O2, and this one is, so you can actually put 1 here. So put 1 here, 1 here. Because there's H2 and H2, so they're balanced, right? 1 H2, 1 H2. And when you do that, you got 1 oxygen here, but you got 2 oxygen here, right? So you can actually place a half there. So half times 2 is 1, right? So that's also fine. If you multiply this by 2, then you get 2, 2, 1, right? Which is exactly the same as the answer above. So Chris, well done. So you were the quickest. Very good. Now, we are now going to move on to something difficult. Everyone's gonna find this one difficult, okay? So the topic is limiting reagent or limited reagent. So I'm gonna talk about a reaction. So let's suppose N2 and then H2. Oh, is it blue is hard to see, is it? Maybe I should change. Okay, I'll just use yellow and what about red? Is that all right? Bit hard on eyes. What about red and green and yellow? So this is yellow, green, red. How about black? Black is fine as well. All right, I'll just use those then. Yeah, I tend to use darker background because you guys are watching this at night, and I don't want you guys to yeah, white is not very good. So I'm going to, so that's 3, 4, 5, 6. Okay, good. 3, 4, 5, 6. All right. So this goes into NH3. Now this one is a synthesis reaction. So synthesis reaction is opposite to a decomposition reaction. Okay, so decomposition is something breaking. So if this one is going into these two, so if it was NH3 going into N2 plus H2, then that will be decomposition. But if these two are going to become this one, then that's synthesis reaction, okay? Now, just going to get rid of this for now. So at the moment, it's a synthesis reaction. In fact, actually, for this reaction, it can actually go backward as well. It's a reversible reaction, by the way. Now, I want you to balance this one for now, okay? Balance this. And Philip, you can also share your answer privately to me if you don't want others to see your answer. So Michelle is doing the same. Just try your best. Just balance this. All you have to do, if the answer is like 1 to 1 to 1, you can just type 1, 1, 1. You don't have to type N2, H2. It just takes a long time. If you think the answer is like 2, 2, 2, then just type 2, 2, 2. All right. That's a lot quicker. You know, like if you think the answer is 2, 2, 2, then just type 2, 2, 2. Okay, Chris, 2, 3, 2. Nearly. 1, 3, 2. Yeah, 1, 3, 2 is the answer. Well done. Yeah, so that was pretty fast. Yeah. Yeah, Michelle, I think you're right as well. From now on, let's not share the answer, okay? Because others, I want others to have opportunity um, to do those questions without looking at the answer. So just do the private message from now, okay? Okay. So the answer is 1, 3, 2. As you can see, there's 2 nitrogen here, 6 nitrogen there, and there's a 6 hydrogen there, and then you have 3 times 2 is 6 hydrogen, and you have 2 nitrogen, so that's all balanced, right? Okay. Now I'm going to say, so even if you get the answer slowly, that's still very good, all right? So the important thing is that you get the answer, okay? So how slow you are doesn't really matter at this stage, okay? As long as you can do this, it's fine. Now, I'm going to say there are 1 mole of nitrogen, and I have 3 mole of hydrogen. So 1 mole of nitrogen, okay? 1 mole of nitrogen, 1 mole of hydrogen will give how many moles of the ammonia? This is known as ammonia, by the way. What do you think? If I have 1 mole of nitrogen and 3 mole of hydrogen, then how many moles of the ammonia would I get? How many moles of ammonia would be produced? I'm getting some responses. Michelle, Philip, just type your answer, private message. Just share your answer to me. Okay. Michelle, still waiting for your response? Just guess if you don't know. Now the question was, if you have, so this is the reaction, right? This is the balanced reaction. If I have 1 mole of ammonia and 3 mole of hydrogen, how many moles of ammonia would I get? And Philip, you got the answer. Oh, Michelle, you said 4. All right, Chris and Michelle said it's 4, and Philip said 2. And 2 is actually correct answer. Can you tell me how you got 4? I'm interested. So the answer is 2 mole. So Philip got it right, but Chris and Michelle, for some reason, got 4. Or you guys just add them. Oh. Right, so you can't just add them like that, all right? So here's the thing. If I tell you 1 slice of ham, 1 slice of maybe cheese, and 3 slices of ham, of course that's a plus, all right, can make 2 sandwiches, all right? Okay? Then if I have 1 million cheese and 3 million ham or bacon, all right, then how many millions of sandwiches can I get? The answer is 2 million sandwiches, right? 2 million. So you're not going to get 4 million, right? So if you have 1 mole of cheese and 3 mole of bacon or ham, then you get 2 mole of sandwiches, right? In a similar manner, if you have 1 mole of this and 3 mole of that, it says it's 1 to 3 to 2. So you're going to get 2 mole of ammonia. Make sense? Pretty simple stuff, right? If I have 2 mole of this, and here's a question again, so answer your, type your answer in the private message, all right? And 6 mole of this, then how many moles of ammonia would I get? I'm getting some responses. Philip, Michelle? Correct. Both of you correct. Michelle, any idea? Okay, so the answer is 4. The answer is 4 mole. So if you have 2 mole, 6 mole, the ratio is 1 to 3 to 2, right? 1, 3, 2. So if you simply times this by 2, times this by 2, and then you should times this by 2, right? Simple. I'm going to give you another question. If I have 1.5 mole of this, the question is, how many of this do I need? And how many of this do I get? Okay, I'm going to type the question. Yeah, I'll read it. I'll just say it again. So how many moles of this do I need to react with 1.5 mole of nitrogen? And how many mole of this do I get produced? Assuming that this goes all the way, I'm going to actually get rid of this sign here. It's going to go all the way. So all of this is going to react to become all of that, okay? So here I'm not giving you. So all I'm asking is, because this is 1 to 3 to 2, and 264 was also 1 to 3 to 2, wasn't it? The ratio is 1 to 3 to 2. All I'm asking is if this is a 1.5, then how much should be this one and how much should be this one? The ratio should be still 1 to 3 to 2. All right, I got one answer. Philip and Michelle still working on it? Philip, you're still working on it or what? If you're still working on it, I can wait for you. Okay, right. I got everyone's responses. Good. Now, let's have a look. So you guys are right, 1.5. And then this is a 1 to 3, right? So this is 3 times this one. This is 3 times this one, right? This is 3 times 6 is 3 times 2. So this one must be 4.5. So well done. And this is 2 times this one, isn't it? You see how this is 2 and this is 1? This is 4 and this is 2, right? So this must be simply 3. Make sense? Now, I'm going to ask you another question. I'm going to go for 5 here. I want you to figure out the other 2 numbers here. So the ratio is still 1 to 3 to 2. Okay? I'll wait for your responses. So at first, it might be a bit difficult. So I got one response. Just say, I've got no idea if you don't have any idea. Or if you're still working on it, I can wait for you. So I've got 2 responses, but one of the, or I got 3 responses now. Only one response is correct. So let's have a look. So this is 5. The answer is 10 on 3. This one here is 5 on 3. So it's about 3.333. This one is, I'm not sure what that is. All right. So you guys can check this, and this is all 1 to 3 to 2. So let's actually work that out with a calculator. Where's my calculator? Okay, so here, I'm just going to put this aside. So 5 on 3 is 1.666. So this is 1.666, and this one is 3.333. So this one is 1 to 3 to 1 ratio. In fact, if I divide this one by 1.666, I get 1. I divide this one by itself, I get 1. And have a look. Can you guys see my calculator? Yes? So if I do 5 divided by 1.666, I'm dividing everything. I'm dividing all these numbers by 1.666, okay? Then I get 3. And if I divide 3.33333 divided by 1.666, then I get 2, right? I get 2. So this is all 1 to 3 to 2 ratio. Now here's how you do it. Whatever number you get, let's say you got 5. So this is a bit confusing number, right? So for this one, it's very easy. If you have 1, 3, 2, so if you have 1, 3, then it's 2, right? If you have 2, 6, then it's 4, because you just times by 2, times by 2, times by 2, right? But something like this one is very, very, you said red color is fine, right? So this one is very, very confusing. because you know, this 5 is not really a multiple of 3. So here's how you do it. If you want to find this number and this number, I'm going to get rid of this. So listen very carefully. You take this number and times by this one, and then divide by this one. All right? Try that. What do you get? 5 times 2 divided by 3. We can divide 5 by this one and then times by this one. Doesn't matter which order you do it. So 5 by 3, divide by 3 first, and then times by 2. And you get 3.333, right? So this is the fastest way. And then you start from 5, and then you divide by 3, and then times by 1. Then you get this number. Okay, so 5 divided by 3 times by 1. Then you get this. 1.6666, okay? Now, let's suppose that I don't have this one. How do I go from here to here? Using this equation, I can do, all right, start from here. This one, divide by 1, and then times by 2, okay? So it's just double, right? So there's 1.666 times by 2, then you get 3.333, okay? So that's a 3.333, okay? Easy enough? I'm going to move on to a more difficult concept. Now, I've got I got N2 plus H2, and that gives us NH3. So we said that this is ratio of 1. You don't have to put 1 though, all right? I'm just putting there anyway. So 1:3:2 ratio. And just for the last exercise, maybe try this one. I'm going to go for 10 mole here, or maybe 10 mole here. I got 10 mole of this. I want you to figure out this and figure out this using the technique that I just taught you, okay? So you can share that answer privately with me. Okay, I got one answer, and that is correct. That is correct. Well done. 2 other people. It's not that hard. This one's a very easy one. Okay, I got 2 responses and that are correct, and 1 response is incorrect. Incorrect. Yeah. I want you to think about that again. So the answer is 5, 15, 10. 5, 15, 10. So this is a 1:3:2 ratio, isn't it? 1:3:2. You just have to take this number, divide by this one, times by 3, then you get this one. You divide this one by 2, and then times by the other one here, then you get 5. So that's the answer. Okay, very good. Well done, guys. Now, I'm going to actually make it a bit confusing now. So now you guys know how to figure out this. Okay, so 1:3:2. I'm going to say I've got 10 mole of this. No. I've got, let's say, 5 mole of this. And here, if the ratios are just right, then I must have how many moles here? The answer is 15, right? We just worked that out. True. I'm going to say I've got 10 mole here. So inside, let's say, inside maybe a container. Let's say this is a container. And inside this container, I'm going to put 5 mole of N2, represented by these 5 N2s, okay, 5 mole. So each of this represents 1 mole, okay? But of course, we know that 1 mole is huge, right? I'm going to go for, all right, I'm going to put 10 mole here. So that's H2, 3, 4, 5, 6, 7, 8, 9, 10, okay? Now, obviously, this is not 1 to 3 ratio. So I've got 5 of these and 10 of that. Question, how many moles? So they're going to react. So these two are going to react to completion. All right? So how many moles of this one would you get? So that's the question. I want you to think about that. I'll give you a few minutes. I'll wait for your answers. I'm going to make it a bit easier. I'm going to write 9 mole here. Instead of 10 mole, suppose I got 9 mole. I'm going to change the question a little bit differently. So let's suppose that we have 9 moles. I'm going to get rid of one of these, okay? That makes it a bit easier to think. Okay. You can still try. Other people still haven't submitted their answers. You can still try. Okay. Okay. One person is saying 4. One person is saying 4, but I think that is not correct. Another person is saying 7. That is incorrect. Another person, the third person. So all of you have submitted an answer. The third person said 6.5. That is incorrect. Try harder. Another person said 7. No. 7.5. No. It's very close. No, a bit less. No, even more. Even less. The answer is 6. I didn't get that from any of you. Okay, here's how you do it, okay? So get rid of this one. So if I have 5 mole, I'm going to write 2 scenarios, okay? 2 scenarios. One based on this 5 mole, another one based on this 9 mole. Okay, so if I have 5 mole, I would need 15 mole. 1, 3, 2, right? So 5, 15, 10 mole. So I didn't get this answer from any of you, but this is the incorrect answer. So I didn't see this response from any of you. Now, if I base my answer based on 9 mole, then 9 divided by 3 times by 1 is equal to 3 here, and I would get 6 mole here. And that is correct. You would get 6 mole here. So this is case 1 scenario based on 5 mole. So I said you're given 5 mole, 9 mole, right? So this is the response based on the 5 mole, okay? And this is the response based on the 9 mole. Okay, so why is this one correct and this one incorrect? Can you guys think? I want you to think about it very carefully. Just say, I understand if you think you understand. Or you can type, I need some explanation. Or you can say, I kind of get it. Okay. All right, let's try. So here's the thing. You're given 5 mole, you see? 5 mole of the nitrogen. But if you want to react all of this 5 mole of nitrogen, see, if you want to react all of this, you need 15 mole. You need 15 mole of the hydrogen. But do you have 15 mole? Do you have 15 mole available? You are just given 5 mole, that's given. 9 mole, that's given. If you want to get rid of, if you want to react all of the 5 mole, you need 15 mole. That's what number 1 is saying. But do you have 15 mole? The answer is no, you only have 9 mole, right? So you're not going to get 10 mole. If you had 5 mole and 15 mole, then you would get 10 mole, right? But because you don't have 15 mole, see, you need 15 mole, but you don't have 15 mole. That's the reason. Now, have a look at this one here. You have 9 mole, 9 moles of hydrogen. But to react 9 moles of hydrogen, how many moles of N2 do you need? The answer is 3. But do you have 3 mole? Yes, you do. You got one here, another here, another here. Oh, no, here. I mean, this one here, this one here, this one here, right? So you have 3 mole because you have total 5 mole, right? So what's going to happen is the 9 mole, so this 9 of these, all of this is going to react with 3 of the nitrogen. And in that ratio, 3, 9, then 6. You're going to get 6. You're going to get 6 moles of ammonia, right? And obviously, because you have 5 moles to start with, and then you have used 3 moles, you're going to have they're not going to react. So Chris, you asked the question. Very good question. You said, what happens to the remaining 2 moles? So they just stay there. They just don't do anything. They don't have any partner. No partner to react. See? They're just going to stay there. So that's the answer. So you get so what's going to happen is the 9 mole is going to react with 3 mole out of 5 moles and produce 6 moles. Okay? So I'm going to give you something similar. Try this now. I've got 10 mole and 40 mole. So I've got 10 mole of this, 40 mole of that. I want you to think about how many moles of this one produced and also how many moles of which is left. Okay, so question 1, how many moles of NH3 produced? Question 2. How many moles of which reactant, so that's the term, these two are reactants, that's a product. Okay, so this side here is product, and you have an arrow. The other side is reactant. This is reactant 1, this is reactant 2. So how many moles of which reactant is left? Okay, so I'll leave you guys to do it. So I already got one answer from one person. So I got one response so far. No, it's not going to be 1 mole. You have 10 mole and 40 mole. You're gonna get at least 10 mole. So whatever the answer is, this one here. Oh, that was a typing error, was it? Okay. So whatever this is, I think it's gonna be more than 10 mole. The answer is more than 10 mole. Okay. So try to figure it out. Chris, I think your answer is correct. So we can sit back and relax while other people. So you were the first to submit the answer. You have 10 mole and 40 mole. I don't think so. Try again, not 25. I don't think it's 25. So you should write 2 scenarios, like the one I have here, okay? Case number 1. So I'm given 10 mole of this and 40 mole of the other. Work out all these numbers based on 10. Work out all these numbers based on 40. Okay? So if I have 10 mole, then this is 30 mole, and this is going to be 20 mole. 1, 3, 2, right? Very simple. If I base everything based on 40, if I have 40 mole, I divide that by 3 and times by 1. So 40 divided by 3, so 40 divided by 3 is equal to 13.33, right? So that's 13.333. And this one is 40 divided by 3 times by 2. 40 divided by 3 times by 2, then I get 26.6. So for question 1, the answer is either 20 mole or 26.666 mole. So you have to pick one of them. So I want you to think more. So, yep, finalize your answer. Submit your answer. Hey, Chris, I think your second answer is incorrect. I thought that was initially right, but your second answer, first answer is correct, but your second answer is incorrect. I want you to look at this chart to figure out which one, what the answer is. So you were initially given this one and this one. 40 mole of this substance. So 40 mole of this guy and 10 mole of this guy. All right, who wants to give up? We're still going. Okay. Another person? Give up or still going? So one person gave up. Okay, another person gave up. Okay, so first answer. Here's the thing. Let's go for scenario 1, all right? Scenario 1. So I've got 10 mole. How many moles of hydrogen do I need? 30 mole. Do I have 30 mole? Yes or no? Do I have 30 mole? Yes, I do. Because I was given 40 mole, right? So 10 mole and 40 mole given, right? So if I want to exhaust 10 mole, if I want to get rid of all the 10 mole, then I need 30 mole of hydrogen. And I do have that. If that is the case, then 20 moles of this will be produced. 1 to 3 to 2, right? Now, if I have 40 mole, if I want to exhaust all of this, like use all of them up, how many moles of N2 do I need? The answer is 13.333, right? But do I have that? Yes or no? The answer is no. I only got 10 mole, right? So this case is wrong. Just need to get rid of it. So this is not going to happen. Now you're not going to get 26.666 mole of this. So the answer is you got 10 mole and you're going to be using 30 mole out of 40 and you'll be producing 20 mole. So how many moles of NH3 produced? The answer is 20. How many moles of which reactant is left? The answer is 10 mole. Of course, out of 40 mole, you use 30 mole, right? So 10 mole of H2 left. Okay, I hope that makes sense. When I call it a day, I'm going to send you homework similar to this one, okay? Maybe you can try this one yourself. This one, try that by tonight. It may look difficult. Yeah, I think this one's fine. Maybe you may not be able to do this one. I don't know. So this one is reacting with this one, with this one. You see, 3 reactants. Can you guys see this? And I'm producing these 2. But it says excess chlorine. So none of so this is plenty of this is available. So how many moles of this are needed to react with? So let's have a look. Let's have a look at the first question here. But I'll send you some more simple questions later. So this is 1 to 4, isn't it? 1 to 4. So if I have 0.12 mole of the chlorine, that's what the question is asking. How many moles of this guy do I need? This is 1 to 4. I just have to divide this one by 4 times by 1. Okay? So the answer is just 0.03. Okay, so it goes something like that. So you guys can try this question tonight. It's a pretty simple one. Okay. Yeah, that's it. So just letting you know, question 18 is not as complicated as this one here. In this case, you have to look at 2 scenarios, right? But this question here, it doesn't require 2 scenarios. Okay, so you don't have to figure out which one is limited and which one is excess. Okay, so try this tonight and let me know of your answers and how you go. We'll call it a day. Any question? Anyone? All right, we'll call it a day. See you guys. You can log off.